Okay, so the folded plate is the next of the methods that we're going to discuss. And the folded plate, once again, could be done like all the other methods we're discussing right now, could be done with any network of curves on the surface. Could be any network of curves that I draw, unless it's got two directions to it. Could pull those to the surface like this, cell last, copy these, undo, paste them. I could make this type of network and use this method on that. But for ease of the tutorial, because it makes sense, if I want to describe the whole surface, I'm going to use the isocurves. So I'll start by dividing the directions and extracting a network of isocurves. And the other direction. And one of these directions is going to be primary for the folded plate, and the other one is going to be a series of profiles that are extruded along it, essentially. So what's going to happen is I need a direction, which could be any initial starting direction, like that. And I need a direction this way. This is a profile. And I'm going to make a straight segment between one point and the next point. And essentially, this profile is extruded along that edge, and this profile is extruded along that edge. And then these two planes are intersected. Then that intersection defines something that is in both this plane and this plane. So I can put a point anywhere along that intersection. And I can draw a surface through those points. So drawing that surface, let me make that very clear. If I extend these surfaces, they will always intersect along this line. So I can trim them by the line. I can trim them anywhere. I can trim them like that. Or I can trim them like that. And where they end determines the profile for the next cell. So I would draw another line like this and another line like this. Extrude this one along that, and this one along that. And I would intersect them using this connect surface command, which sometimes doesn't work. And then I have to manually intersect. They define another profile curve, which once again extend and end at any point. And so I also wanted to show you that once I have that intersection curve, I can draw something through the 2 points that started the plane, the 2 points, any 2 points on that intersection curve will make a plane with this. This is getting a little confusing right here. So that I'm going to backtrack. Essentially, if I have this curve here, extending in between those planes is the same. It's just drawing a panel from the edge that I used to start this plane and the other edge. So I'm going to try this again. Hopefully this will be a little more understandable this time. Draw an edge here. Draw an edge there. Extrude this. Extend that till it intersects with that. And create the planes. Now, why it's getting very close here, what's going to happen is it's going to switch sides of the surface. So that's fine. You'll that'll become clear as I go along. Okay, so that's what the cell for one of these surfaces looks like. So now, in order to do the whole surface, it helps to be consistent. It helps to start with the same relationship in every profile and find a consistent cell so that it works out. So one of the things I often do is draw the normal from each of these points at a consistent length. Let's say 15, 15, 15, 15, 15, 15, and then once I have those normals, I could divide them into, I don't know, 4 parts, and I could use that to draw one set of profiles. And then I could draw this profile, say divide this into a certain number of parts, but I'm just going to do it to the midpoint for now. Like so. And then I have a set of starting profiles that are consistent in their angle to the original surface. And then I can select these other isocurves. And let me hide the surface for now. Select these isocurves, split them, rebuild them, 1 degree, 2 points. Now they're all straight segments. And then I can go along left. Made a mistake here. Look at that. Like that. And then I can intersect them. They are starting to cross the surface, which is fine. There's a backwards triangle that's getting created here. These it didn't happen. Okay, so then once I get to this moment, what I can do, if I don't like that that's happening, it is possible to pick a different starting profile. So I'm going to try that. I'm going to try a different starting profile. Maybe it'll be clearer. It won't cross the surface. Yeah, this one's easier to see. Okay, so then I have all these intersection curves like that. And what I can do is I can pick really anywhere along that intersection curve to end it. So it just helps to be consistent. So what I'm going to try to do is find the nearest point from these intersections for now. I mean, you could make it overlap or something else, but I'm going to draw perpendiculars like so. Okay, like that. And then what I'm going to do now is use these curves to start the next row. So let's make another row. So there's the intersection curve. So often I'll just find the intersection curve, delete the surfaces. So I'll extend this curve. Find the perpendicular. And then because this one's crossing the surface, I'm going to get a triangle there, it's plane, like, oops. That plane like that. Find the intersection curve. There's the intersection curve. So from this point to there, this plane trimmed with this surface and that surface results in two triangles. And then this plane trimmed with that surface and a line to that point. There we go. Like that. I think it's easier just to find the intersection curve of the two planes. And use that intersection curve to help me find the correct planar surface by just drawing it in there. There's the intersection curve of this plane and this plane. This plane also includes this line. So I know this line and this line are included in this plane. So that means that any surface drawn that includes both those lines point, there we go, will be also the same plane. this plane, I'm just scaling when I do this, scale, 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 this plane. And that plane includes this line and this line. So I can draw, yeah, I can draw from this point and extend this line. Draw a point from here to the perpendicular. And then I can fill in I screwed something up because these lines should intersect. So let's go back. Yeah, I moved the plane, you see? Okay. That plane goes to there. That's the line. Right, that's another row. Now I'm getting these weirder profiles. So let's keep going. But actually, they're a little more straightforward, as you can tell, because they've switched sides of the surface already. Okay, so let's intersect these. Intersect those using the connect surface, which, as I said, sometimes doesn't work. And then this one's messed up, so I gotta intersect. Something looks funny there. I didn't extrude it in the right curve. This one's crawling back. Okay. So now I need to figure out where to end them again. Was following this rule that I made of ending at the perpendicular, even though there's, I could also end by setting a multiple of this particular length or any other rule that would be consistent. That, okay. And now I got another cell to do. like so. That one looks like I messed up again. This little thing has to be extruded along that curve. There's the intersection. This point to there. Okay. There we go. They're all crossing back again. Okay. There you can see the crisscross quite clearly. And one last cell. Let me connect this that one, so I'll have to handle it. Let's find the perpendicular. Okay. Then I have something like that. Which is another approximation of the surface. And essentially each cell is replaced by each area of the surface replaced by a plane coming from one edge, a plane coming from the other edge, and they intersect at a line in the middle. Okay, now, for our purposes also, there is an automated method that I've created for this. If you go to Grasshopper and you open up your discretization folded plate, you need the main Coon plugin to make this run, which you can get from me. And this one does it from curves. This one does it from a surface. And this is to attach one to a series that you've already started. Okay, so the way this runs is like this. This is the input of the surface. You right click here, you set one surface. And essentially, again, I can turn off the preview. This gets a bunch of isocurves like that. If this is one set of isocurves, this is another set of isocurves. So if you have it using the wrong one, you need to flip which one is connected here. That one, if you click on it, are those, that one are those, and you can drag the other one into here. This is the number of divisions that it's going to be divided into that way. So actually, the other control here that's controlling the number of curves in the other direction is not really actually relevant after this moment when you decide which way to go. This control is the number of divisions that curve is divided into. So I probably should have connected this one into there instead, but since this is a moment where it might switch which one is primary, it has to be done this way. So you'll have to control this. This just gets the first order of the curves. This one sets the divisions, okay? Then this creates those divisions. This draws a new polyline that replaces the curve. Like that. And then this section here is splitting them into pairs. 1, 2, 3, 4, 5, 6, little into pairs of 2. That's what this does. And then this, all of this is just to draw the profile. So that could have been done in different ways. I picked one method. So it's getting planes at the edges, and then it's drawing lines, which you can control the length, and it's drawing lines on the other side, essentially, and then drawing a bunch of angles like that, and drawing a bunch of angles like that. So if you change the length of these, it changes the initial vector of the input curve. And then those are the profiles, and those profiles are fed into the component folded plate from the main Coon, which generates the rest of it. And you can right click on that. So if I go over here, what I can do is change the number of divisions. Change the initial starting profile. If I bring that one of them down to 0, it'll start with triangles like that. Bring the other one down to 0. And then I can bake this. Like that. Okay. And then if I want instead, if I have something like that already, there we go. And I want to keep it going, all I need to do is can extend some curves from those profiles. And I can draw the profile. And this I can put into this edges. Just set one joined curve in here, and this will split it and take every other one. And then I can take all these profiles and I can put them into the profiles. Sorry, this should say profiles. This should say edges. And you might have to flip the direction of that so that it's aligned with the same direction as the curves. And then that is going to produce more folded plate like so. So you can actually just drag these around and it's producing it. You can actually just draw a profile if you wanted. Any profile. It'll do it. Also, if I just had all these curves by themselves and I just gave this like 2 random profiles, the Maine Coon plugin will just use those for all of them. So it's just using the same exact profile for all of them. So if I wanted to say, make these into kind of steppy things, I would just have to make sure that this one of these profiles was horizontal. And now they're all always horizontal. So if I bake that with one of the profiles horizontal, these are always going to be like stairs. See that? And I could do that, by the way, here as well. So I could go back to this one over here, and where it's creating the profiles, here are the profiles, there are the other profiles. Instead of using all of these, I could just draw a horizontal line. Probably I'd want to bake these profiles so that I can orient the horizontal line roughly in the right orientation space. There's a horizontal line. And I could make a new curve right here. Just double click, type curve, right click on this, set one curve. That's a horizontal line. And I could replace this profile here with that. And now they're all going to be horizontal. And that is like a super crazy, well, it's actually just the first run with the profile that's horizontal. So they're going down actually at funny angles after the first one. We'll go over how to, it's only the very first one that's horizontal in the row, although this one looks like they all stayed horizontal. So it might or might not work to make it fully into steps, but at least the first one will be steps, and then it may deviate as the surface goes up and down. Okay, so that's that. And then the last thing is if you had, so this is a mesh I had that's another 5 surface, and if I extracted the curves from this mesh, like I did here, I had a bunch of curves, just any old curves. I take these curves and I can put them in here to this from curves and put a series of curves. And then those curves are also going to construct the whole folded plate. And the way that works is it's using a different method to create the initial profiles right here. It's just rotating them a certain angle off of a straight horizontal line. So you can do it that way as well. And if you wanted to just draw the straight lines, rather than this control is setting the number of divisions. If you wanted to input polylines that already had divisions rather than curves, put those in here and exchange that with this. So this whole portion of the script up to here is dividing the curvy curves that you put in into a certain number of divisions, making polylines and putting them in here. So if you had instead already a bunch of polylines, you could put those in here and exchange that with that, and we'll use those curves. Okay, so that is the folded plate method. That's